Hi students, how are you doing? I hope you'll be doing great. Well, those who are absent in today's class, especially this video gonna be important video for them. Tomorrow when you come back to the school, so probably this is gonna help you to discuss more about the topic. Okay, for the video. So we get started. So today's topic is about Hess law. Okay, the Hess law seems to be difficult for some students. However, I would say today, by watching this video, it's gonna be really amazing, and this is pretty cool and absolutely easiest one, I would say, in the chemistry topic. Alright, so let me get going with this topic first. What Hess's law? How you can define it, and what is the need of Hess's law in the chemistry? This law is based on the first law of thermodynamics. First law of thermodynamics says that energy cannot be created or we cannot destroy even, but it can transfer from one form to another form. Alright, let's say heat energy to light energy, light to heat. For example, now I'm talking to you, you could be able to hear me. Yes or no? So my sound energy is being converted to electrical and then again to heat. So energy transfer takes place only one form to another form. Heat to light, light to sound, sound to heat. Hess said that in the chemical reaction, energy will be remain same. There will be no loss or no gain during the chemical reactions. Alright, so how? So basically, for understanding this law, whenever the chemical reaction is happening, we tend to measure the energy change. What we tend to say is enthalpy change. Well, so energy change of a chemical reaction can be easily calculated by means of calorimetry. Okay, by means of calorimeter is a device we can use to measure the heat changes or the energy changes takes place in the chemical reactions. However, some of the chemical reactions which cannot be determined directly through the calorimetry. Therefore, Hess's play a key role in order to calculate the energy change of the chemical reactions and for law. So Hess's law says that it states that total enthalpy change will be remain same in the chemical reaction. No matter the route it takes. Okay, so the reaction path doesn't matter whether you go directly or indirectly, one step or through the several steps. So it states that the total enthalpy change also can be written just simply energy change, will be remain same in the chemical reaction no matter the route it takes. Did you understand? I don't think so. You might have understood from the definition. If I give an example, then pretty sure it's going to be understood by you. Alright, so let's suppose you wanted to go to New Delhi. His Kejriwal is conducting a rally. So let's say your aim is to go to attend the rally in New Delhi, and in your pocket you just have 5,000 rupees. Alright, how much money do you have? You have just 5,000 rupees and you wanted to go to New Delhi. So this is your, let's say A point to B point. This is New Delhi. This is the Vizag. Okay, A point is this is your initial starting point, this is your end point. So you can go directly So this is the initial point. The initial point is Vizag. Final destination is New Delhi. So you want to fly. I mean, you wanted to go through the plane directly, but you feel like you are, getting scared in the flight, in the plane. Therefore, you thought that no, let me just go through the train. So you starting point here, Vizag. So some trains are not direct trains. Okay, some trains you need to just sit or switch the train once or two times, then you can get into the destination. So let's say from Vizag to BBSR again, Bhubaneswar. Okay? Again from Bhubaneswar, one more train you just hired, and then just you went to the New Delhi. Okay, from Bhubaneswar to New Delhi. So this is called indirect path. Okay, so indirect path through train. It is several steps. You Vizag to Bhubaneswar, Bhubaneswar to New Delhi. So in your pocket, how much rupees you have right now? 5,000. Whether you go through this way or you go directly, you go through the flight or you go through the train. Destination is New Delhi, and the money also same. In the flight also 5,000 rupees maximum they may take. Yes or not? If you book the ticket in advance. So your money in 5,000 you can reach in the New Delhi. In the same 5,000 in AC berth you can reach in the New Delhi through the train. So whether you follow the multiple step or you go directly, the money will be remain same 5,000 and the destination will be not changed. Okay, you will be reaching of course in the New Delhi. So this direct path will be equal to the indirect path. For direct path, how much rupees you have spent? 5,000 rupees. For indirect path also, how much you have spent? 5,000 rupees. So money is remain same whether you go through the flight or you go through the train. Destination also the same. So this is the law of Hess. So now by means of a chemical reaction, let me explain. Okay? By means of a chemical reaction, let me explain. Well, let's say this is called carbon, and when you react with oxygen, it produces carbon dioxide. Alright? So this is soluble state, oxygen is gas in standard state, and carbon dioxide is also in gas. So, for formation of carbon dioxide, what is the amount of energy released when we burn carbon in presence of oxygen? How much energy is released? That energy is also said to be enthalpy. Alright? For formation of carbon dioxide, let's say we tend to write energy change in the form of delta H. Okay, delta is basically called enthalpy. Enthalpy or energy change. So let's say this is called carbon will react with oxygen to form carbon dioxide. For formation of carbon dioxide, we need to have how much heat energy will be released? Around 393.5 kilojoule per mole energy will be released. So negative symbol describe that it is an exothermic reaction. Heat is getting out or heat will come out. Alright. However, if you go through the different step, if you go through the multiple steps, then what you have? This carbon need to be added with one oxygen. This is oxygen standard state, so how can you make one? So if you multiply here half, then it will become 1, 2 to cancel out, so it will become oxygen. So firstly, you have to add oxygen to the carbon, therefore it will be carbon monoxide. Understand? And then from carbon monoxide, again you have to add one more oxygen. That means you have to just write like this, half into 4, that means it is 1 oxygen. Okay? Then you can get carbon dioxide. For formation of carbon monoxide, how much heat energy will be released? So here already I have written enthalpy change delta H. So therefore, can I write here delta H1? Yes or no? So delta H1. So formation of carbon monoxide, how much heat energy is released, you know? It's around negative. Alright. And when we add this carbon monoxide with one more oxygen, with this oxygen, so how much heat energy will be, or what is the energy change? So let me write this delta H2. So it will be around 200, negative 283 kilojoule per mole. Now Hess said that in the direct path, how much heat energy or energy change takes place, that will be equal to the successful path. That will be equal to the indirect path. So I will write, according to Hess's law, he says that the energy change, energy of direct path will be equal to energy change of indirect path. Alright, so direct path energy will be equal to the indirect path of energy. So how much energy is released in the direct path if you just carbon dioxide reacted with oxygen to form carbon dioxide? This much of energy is produced. Okay, so it is 393. So if you go through this way also, if you follow the multiple steps also, the energy will be equal to negative 393. Can we get this is negative 110.5. So this is fine. Then plus here we have delta H2. We have about negative 83. Then negative plus into minus this minus. Plus into minus. Directly let me write it. Then it will be equal to the same 393.5. Is there any loss or any gain? So energy same is remain same. So this is called Hess law. This is known as Hess. Is it clear? So Hess law says that the total amount of energy will remain same whether the reaction takes place through one step or several steps. The energy change will be remains same. So in the formula, if you like to write, then you can write this is delta H, energy change will be equal to delta H1 plus delta H2. You can follow this one. This total energy you can get if you add the intermediate one in the several step, delta H1 and delta H2. Enthalpy, total enthalpy change, it is enthalpy change of first reaction, enthalpy change of second reaction. That energy will be equal to the total energy change. So I would say there is no loss or no gain of energy. Hence we can say it satisfied the law of conservation of energy. So energy neither be created nor be destroyed. Is it clear? I think the Hess law is clear. In the next class we are going to discuss about the application of Hess's law. And if you like to write, you can probably write this example. Alright, so is it clear? So thank you so much for watching this video.